For any homework-related queries, call us at +1 678 648 4277. You can mail us at info@architectureassignmenthelp.com or reach us at https://www.architectureassignmenthelp.com. 1. The courtyard in the center of the Gardner Museum in Boston is enclosed with a glass roof. The glass is supported by a steel frame. The steel, 2 centimeters thick, extends in a solid piece from the inside to the outside as shown in the figure. The outside surface of the steel is painted black and has a convective heat transfer coefficient of 5W/m2 The outside air temperature is 0 OC. Assume the inside surface of the steel is painted with a silver paint that has an emissivity of 0.1. The inside convective heat transfer coefficient is 3W/m2 The inside air temperature is 20 OC and the relative humidity is 45%. Assume the steel surface on the inside radiates to a black body at 20 OC and the steel surface on the outside radiates to a black body at 0. Problems. At 20 OC and the steel surface on the outside radiates to a black body at 0 OC. A. Draw the electric analogy for the heat transfer through the steel frame by using the linear form for radiation heat transfer, HR. B. What is the inside temperature of the steel frame? C. Will water condense on the inside surface of the steel frame? D. If the inside surface of the steel is painted black, will this cause worse condensation problems? architectureassignmenthelp.com. Outside air tout equals 0 C black surface, H, convection, equals 5W/m2 Inside air tin equals 20 C, RH equals 45% silver surface, emissivity equals 0.1 H, convection equals 3W/m2 2. The following figure shows an air conditioning system. Fresh air, T1 equals 35 OC, relative humidity RH1 equals 50%, flow rate M1 equals 3 kg/s, is mixed with the return air, T2 equals 2, relative humidity RH2 equals 60%, M2 equals 7 kg/s, to achieve state 3 in front of the cooling heat exchanger A. The air reaches state 4, T4 equals 14 OC, relative humidity RH4 equals 100%, after the mixed air, state 3, passes through the cooling heat exchanger A. Because the state 4's AI temperature is too low, the air will be heated by an electrical heater B before it is supplied 5 OC, or to the room at state 5, T5 equals 18 OC. The exhaust air from room has same state as return air. architectureassignmenthelp.com. Assumed that the ducts and room facades have no heat transfer and no air leakage. The energy consumed by the fan in this air conditioning system can be neglected. For air, Cp equals 1.01 kJ/kg.OC is constant in temperature range of 14 OC to 25 OC. Questions. A. Calculate the total energy consumption, kJ/s, of the cooling heat exchanger A and electrical heater B. B. If the air condicio, vapor, is generated in the room, in G/s. C. Draw the air conditioning system's air. Please label states 1, 2, 3, 4, and 5 clearly. architectureassignmenthelp.com. Problem 1. A. The electric analogy for the heat transfer through the steel frame can be drawn as: for steel material, its conductivity K equals 15 W/m.K, the value of L/K for this. Solutions. For steel material, its conductivity K equals 15 W/m.K, the value of L/K for this steel frame is 0.02 m/15 W/m.K equals 0.0013 m2.K/W. It is very small comparing with convection and radiation R values. So the conductivity R value of the steel frame can be neglected and the steel frame has a uniform temperature Ta. Then the electric analogy can be simplified. Architecture assignment help.com. B. We can calculate the total R value of the steel frame as, where, then the total R value of the steel frame can be gotten, the heat transfer through the steel frame Q equals, that is to say, the temperature of the steel frame is, architecture assignment help.com. From psychometric chart, the dew point temperature of the indoor air, 20 OC, RH equals 45%, is around 7.9 OC, which is higher than the steel frame inside surface temperature, 5 OC. That is to say, the water will condense on the inside surface of the steel frame. C. If the inside surface of the steel is painted black, the radiation heat transfer through the inside surface will increase, which will increase the total heat transfer through the steel frame. Then the temperature of the steel frame will increase, which will cause better condensation problems, reducing condensation. If we calculate the temperature of the steel frame using black inside surface, we can get the temperature of the steel frame equaling to 8.83 OC, which is higher than the indoor air dew point temperature, 7.9 OC. Problem 2. First, we may need to calculate the parameters of state 3. From psychometric chart, we can get state 1, enthalpy H1 equals 81 kJ/kg air, humidity ratio W1 equals 17.8 G/kg air. State 2, enthalpy H2 equals 56 kJ/kg air, humidity ratio W2 equals 12 G/kg air. Architecture assignment help.com. Mixing state 1 and state 2 air achieves state 3, we have equations. A. From psychometric chart, we can get state 4, enthalpy H4 equals 39.5 kJ/kg air, humidity ratio W4 equals 10 G/kg air. The energy used to cool the air from state 3 to state 4 by the cooling heat exchanger A is the energy used to reheating the air from state 4 to state 5 by the electrical heater B is. So the total energy consumed by the cooling heat exchanger A and B is 280.4 kJ/s. Architecture assignment help.com. B. If the air conditioning system is running under steady state, the moisture generation in the room is. C. Please see the attached psychometric chart. Architecture assignment help.com.